Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to summarize what we've learned in the last two videos about curve sketching. If you haven't taken a look at the previous two videos, I strongly recommend that you do so, because this might not make sense otherwise. But what we talked about is the function increasing, decreasing, concave up, concave down, maximum points, minimum points, inflection points. So I want to summarize all of the information and all of the requirements. So to start with, we talked about when the function was increasing and when it was decreasing. And basically, if the first derivative is positive, then the function is increasing. So it's increasing where our first derivative is positive. Our function will be decreasing anytime the first derivative is negative. So the intervals where the first derivative is negative, the function will be decreasing. Then we talked about concavity, and the function will be concave up, open up, if or where the second derivative is positive. And the function will be concave down, or it will open down, wherever the second derivative is negative. So the first derivative tells us about increasing, decreasing, and the second derivative tells us about concavity. Then we talked about specific points. So we talked about maximum and minimum points and inflection points. And each of those points have two conditions. To summarize, we will have a maximum point at x equals a if the first derivative at that value equals 0. So that's one of the conditions. A maximum point has to have a derivative equal to 0, but there's another condition. The first derivative has to change from positive to negative through the point. So it goes from increasing to decreasing as you go through that zero derivative point. So those are the two conditions for a maximum point. Similarly, you will have a minimum point at x equals a if the first derivative is 0. So maximum, minimum points have to have a slope of 0 or a derivative of 0. And the slope or the derivative has to change from negative to positive through your point x equals a. So negative means it's decreasing, positive means it's increasing, and if it's 0 at that x equals a, then you know that you have a minimum point. So two conditions: the derivative has to be 0 and the derivative has to change from negative to positive as you pass through the point. Lastly, you will have an inflection point at x equals a if the second derivative at that point, at that value of x, is equal to 0. So the second derivative has to equal 0 at that point. And the second derivative, not the first, changes from positive to negative. So that would be concave up to concave down, or negative to positive, so concave down to concave up through that point x equals a. So two conditions for it to be a maximum point, two conditions for it to be a minimum point, and two conditions for it to be an inflection point. So if you have that information summarized, it might help you when you're doing these graphs. Now that we know how to find maximum and minimum values of functions, we're going to use that in order to find maximum and minimum values of a problem, or to do optimization problems. So when you're ready, I'll see you on the next video. Take care.